Hello and welcome to Year 11 Probability. What we've got here, what we're going to start with is looking at probability calculations, things like sample spaces, complementary events, probability tables, Carnot maps, Venn diagrams, addition formulas, and a few other things as well. A lot of terminology within this topic, but hopefully we'll get through it and it'll all be okay in the end. Basically, what we're going to do, first thing we're going to do is have a look at this thing called a sample space. Now, a sample space is anything within a set of numbers. So let's say we've got a fair six-sided die. So the numbers, stock standard dice, numbers 1 to 6. The sample space, this funny E symbol, is then the numbers 1, 2, 3, 4, 5, and 6. So that's our sample space for a six-sided die. So that's something you have to list. Now, let's say we've got A, we're saying is all the odd numbers within the sample space. That means that A is the numbers 1, 3, and 5. Now, if you want to calculate probabilities, well then the probability of A, so the probability of getting an odd number, is equal to the number in A over the number in the sample space. So we end up with 3 over 6, which is equal to 1 over 2. So that's how we go about calculating probability. So it is the number of whatever we're interested in over the number in the sample space, the number of all total possible outcomes. Now, let's change things up a little bit and let's just see how a couple of things work. Let's say event B is rolling a 1 and event C is a 6. Not the 1 like I've got there, and I'll change that into blue, but a 6. So probability of rolling a 1 is 1 out of 6, and the probability of rolling a 6 is also 1 out of 6. Now, what we've got here, this thing, the probability of B, and then this funny looking U and C, that means union. That means the probability of B and C, or B or C happening. So now, in terms of what we've got here, we're dealing with the dice. So, is it possible to roll a 1 and a 6 at the same time? No. So as a result, these two things, B and C, are mutually exclusive. So, and if things are mutually exclusive, to find out what B or C is, we just add those probabilities. So it's the probability of B plus the probability of C. So then we've got 1/6 plus 1/6, or funnily enough, give us 2/6. So that's what it looks like if events are mutually exclusive. So far we've covered the idea of sample space, the idea of an event within a sample space, how to calculate probability, different outcomes within an event. If we've got how to assign other probabilities, and this idea of union, or the concept of OR, is found with, we add the two probabilities that we're dealing with. If B and C are mutually exclusive, which means that they cannot happen at the same time.